What's up guys, welcome back. So today we're going to do more trig equations, but we're going to look at doing multiple revolutions, so going around the unit circle more than once. If you haven't watched the previous video where we just do one revolution, make sure you do that. But with that said, let's get into it. So here's our first question, tan 2x is equal to 1. Now, whenever you see this number in front of the x, so in this case 2, that tells us we're going to go around the circle twice. So I'll tell you what that means specifically, but just keep it in mind, we're going to go around the circle twice. Okay, now what we're going to do first is we're going to say let u equal 2x. I'm going to make it feel like something we've done before in the previous video. So tan u is equal to 1. Okay, now we're just going to solve as though we're solving for tan u is equal to 1. All right, now all stations to central tells us tan is always positive in the first and the third quadrant, okay? So when is tan u equal to 1? Now that comes from your exact value triangles. And you'll find that opposite over adjacent will be pi on 4, so 1 on 1. So therefore u is equal to pi on 4. So let me just put that down first. Okay, now I fill in my quadrants. So I know that pi on 4 goes here, and pi on 4 also goes here. Okay, now I put in my values going around the unit circle, so 0, pi, but instead we're going to write 4 pi on 4 because there's a denominator of 4 in the solutions, and going all around the circle 2 pi will be 8 pi on 4. Okay, so reading this will be pi on 4, and my other solution will be 4 pi on 4 plus pi on 4, so 5 pi on 4. Okay, now the question's not done, but we're close. So we let u equal to this, okay? So we let u equal to 2x. Now 2x tells us we need to go around the circle twice. So what we need to do is, you need to add 2 pi to this solution and that solution. Because we're gonna go around once, and this would be the second time, so going around here, and this would be also around the second time. So our solutions are gonna be another 8 pi on 4 plus pi on 4, so that's 9 pi on 4. 8 pi on 4 plus 5 pi on 4, that's 13 pi on 4. So you just need to add 2 pi to both those solutions because that is going around the circle twice. All right, so we're almost there. Now we just made this thing up u. U is actually 2x, so I should write 2x is equal to all of the above. All of the above there. And I just solve like a normal equation. So I want to divide both sides by 2. So x is equal to pi on 8, 5 pi on 8, 9 pi on 8, and 13 pi on 8. Okay, then you're done. Okay, here's the next example. Sine 3 theta equals -1. So once again, the 3 theta tells us we're going to go around the circle 3 times. So as you saw from the example before, we're going to have to add 2 pi to each solution 2 times because we're around the circle 3 times. All right, so straight away, we'll say let u equal 3 theta. So sine u equals -1. Because sine is equal to -1, that's what we call a boundary angle. So you'll need the actual sine graph. Now that goes between 0, -1, and 1. That's pi on 2, pi, 3 pi on 2, and 2 pi. Should have done that bigger. Okay, so when is sine u, or when is sine equal to -1? So you can see here, well, that's obviously not to scale, but sine is going to be -1 at this point here, 3 pi on 2. So u is equal to 3 pi on 2. But because we're going around the circle 3 times, we need to add 2 pi twice. So going up from this, 2 pi plus 3 pi on 2. So let's figure out what's 2 pi with a denominator of 2. Well, that's going to be 4 pi on 2, isn't it? Okay, because that's over 1. All right, so 3 pi on 2 plus 4 pi on 2, that's 7 pi on 2. We need one more solution, going around 3 times. So add another 4 to 7, that's 11 pi on 2. And then finally, we need to redo the substitution because we just made this thing up u. So 3 theta is equal to 3 pi on 2, 7 pi on 2, 11 pi on 2. Divide both sides by 3. So theta is equal to 3 pi on 6. 7 pi on 6, and 11 pi on 6. And finally, just simplify where you can, so always write that as pi on 2. And just finish writing these ones here. Okay, done. All right, let's have a look at this example. So sec 3x over 2 is equal to minus 2. This one's a little bit trickier, but let's work it out together. Now, I know that sec is the inverse of cos. Okay, so first things first, let's say let u equal to 3x on 2. So sec u is equal to minus 2. Now, using the reciprocal of sec and cos, I'm going to say 1 on cos u is equal to minus 2. Okay? Let's get cos u by itself. So just replacing cos u and minus 2. Sorry, switching, I should say. So cos u is equal to minus 1 on 2. And now I have something I can work with. So I can see that cos u is equal to minus a half. So let's draw out our all stations to central. And since cos is negative, it's going to be in the second and the third quadrant. Now, how do we get cos to become a half? Well, that comes from our triangle. So we've got pi on 3 here, pi on 6 here. So I think it's going to be pi on 3 because adjacent over hypotenuse is a half. So I'm going to put in pi on 3 and pi on 3 in my quadrants. Now you see here, because we're going around 3 over 2, that's 1.5. I'm just going to go around twice, and then I'm going to check the values if I need to delete anything. It just makes it easier to think about. So I'm going to overshoot the mark and then just bring it back. Okay, so just put in my values. That's 0, 3 pi on 3 for pi, and that's 6 pi on 3. So my solutions for u should be 2 pi on 3, because 3 pi on 3 minus pi on 3, and also 4 pi on 3. Now, because I'm going 1.5, or for our sake, we're going twice around the circle, I'm going to add 2 pi to both those solutions. So that's going to be 8 pi on 3 and 10 pi on 3. Okay, so now we need to replace the u with 3x over 2 because we made that substitution. And now we just solve like a normal equation. So we're going to basically times the top by 2 and divide the bottom. Sorry, times the top by 2 and then times the bottom by 3. So here we go. 4 pi on 9, 8 pi on 9, 14 pi on 9, and 20 pi on 9. Now that should be my solutions so far. Now I know that my solutions can't be bigger than 2 pi. So I just need to check probably that last value there. Just need to check that last value there. So is 20 pi on 9 more than 2 pi? So without using a calculator, I know that 2 pi, I'm trying to get that with a denominator of 9. Okay, so all I need to do is make that into a denominator of 9. So times the bottom by 9, times the top by 9, that's 18 pi on 9. So I know my solution cannot be bigger than 18 pi on 9. Okay, I know my solution can't be bigger than 18 pi on 9. So here I need to cross out that 20 pi on 9. So I need to get rid of that. That is done. All right, so this is the last one here. A bit of a tricky one. Sine 3x plus pi on 18 equals negative 1. Same process. Let's say let u equal 3x plus pi on 18. So sine u is equal to 1. Now, hopefully you remember from the other example, similar boundary angle this time, but we want 1. So that's going to be pi on 2 there. So u is equal to pi on 2. Okay. Now, we're going around 3 times and a little bit. So we're going around 3 times and a little bit. So because we're going 3 times and a little bit, let's just go 4 times and then just cross off anything that doesn't fit within the domain of 0 to 2 pi. Okay, so we're going 4 times. So we need to add on 2 pi onto this solution. We need to add on 2 pi onto that solution. I just realized I've changed color, but let's just keep going with it. So 2 pi with the denominator of 2, that's 4 pi on 2. So I need to add 4 pi on 2 to my solution. That's 5 pi on 2. Add another 4, that's 9 pi on 2. Add another 4, that's 13 pi on 2. All right, but u is equal to 3x plus pi on 18. So replace the u. Okay, so now we're going to subtract pi on 18 from all those solutions there. So pi on 2, 5 pi on 2, 9 pi on 2, 13 pi on 2. But just to practice, instead of just pumping numbers in the calculator, let's just do it by hand, because I can just quickly convert all these solutions on the right-hand side to have a denominator of 18, but times top and bottom by 9, okay? So that's going to be 9 pi on 18, 45 pi on 18, 81 pi on 18, and 117 pi on 18. So that's 3x plus pi on 18. Now I can start subtract away the pi on 18. So 3x is equal to 8 pi on 18, 44 pi on 18, 80 pi on 18, and 116 pi on 18. Lastly, just divide through by 3. So x is equal to 8 pi on 54, 44 pi on 54, 80 pi on 54, and 116 pi on 54. All right, lastly, I just need to check this probably last solution, because we've gone 3 times plus a little bit, so we've actually gone 4 times. So is 2 pi bigger than this number here? So let's just check. So we need 2 pi to have a denominator of 54. That's times top and bottom by 54. So 2 times 54 is 108, I believe. So 108 pi. And as you can see, this last solution does not fall within the range of 108 pi on 54. So I just need to cross off that solution there. Okay, and then finally, simplify where you can. So I believe that's 4 pi on 27, 22 pi on 27, and 40 pi on 27. And you are done. Okay, that's it for this video. If you enjoyed, give me a like. And if you want to see more videos like this, let me know in the comments below. Otherwise, I'll see you in the next one.